Hi, welcome back. This is Nandini Tripathi from Roots Academy. I run my coaching institute which is located at Mira Road. Today's topic is from physics, that is magnetic effect of electric current for class 10. In this chapter you're going to learn the magnetism shown by the electric current. So let's start with the session. We already learned about the heating effect of electric current. Okay, we know that glowing of bulb, it is a best example of heating effect. Okay, in a bulb there is a tungsten filament which due to the electric current it get heat up, and that is the reason the bulb glow. Again, straightening machine, the hair straightening machine is again the best example of what heating effect. Okay, due to the electric current the plate get heated up, and that is the example of what heating effect of electric current. So there are several examples in our day-to-day life which through which you can understand this concept. Today we will talk about the magnetic effect. Means due to the electric current you can produce a magnetism. Okay, you can see the magnetic effect. Okay, like if you take a nail, okay, on a nail, if you coil that nail with a copper wire, insulated copper wire. So if you coil the nail with the insulated copper wire and then connect that copper wire with a battery, okay, and if you on the battery, what will happen? The current will flow. Once the current start flowing, that nail will start behaving like what? Magnet. The nail will start behaving like magnet. It will start attracting a small staple pin, which confirm you that through the passage of electric current you have converted that iron nail into a magnet. So as soon as you stop the battery, as soon as you stop the electric current to flow, what will happen? The nail will not behave like magnet. So it proves that with the help of electric current, the nail start behaving like what? Magnet. Thus, you can produce a magnetic effect by electric current. So this electric current, it depends on two factors. It depends on the strength of electric current flowing in a conductor, that is in the copper wire, and the number of coil, how much number you have coiled that copper wire. Okay, more the coil, there will be more electric current flowing in. That means in a straight conductor, like our wire at our home, in a straight conductor, straight copper wire, you cannot see, or you will see a very less magnetic effect. Okay, so your magnetic strength depends on two factors: the number of coil, and second is your strength of electric current. Okay, with the help of electric current we can able to produce what? Magnetic field. Now, before going in more detail, we will try to understand about the magnet, about their poles, and about the magnetic field. Now, we see a magnet in various form, various shapes, size. Okay, the most common one is bar magnet, which we usually see in our laboratory. Okay, in our science lab. Okay, to carry out lot of experiment. In a bar magnet, there are two sides, north pole and south pole. When you suspend when you suspend this magnet, it means when you tie the magnet and freely leave it, there will be a point, the pole which is pointing towards the north is the north direction, whereas the side which is pointing toward the south is actually your south direction. Okay, it means in this, the like poles, they repel. Means north will repel, south will repel. If north pole of magnet is brought near to the north pole of another magnet, it will repel. South pole of magnet, if it is brought to the south pole of another magnet, it will repel. Here the different poles, that is unlike poles, they get attracted. It means north pole get attracted towards the south pole and south pole get attracted towards the north pole. So 2 point again I can conclude, that is repel, the same pole they repel, and unlike pole they attract. So my next topic is magnetic field. Just like electric field, there is also a magnetic field. What is magnetic field? The force exerted by a magnet to a surrounding area of a magnet is called magnetic field. Like if you place a magnet and if you keep a compass near to that magnet, and if you see that compass is getting deflected, this prove that that compass is under that magnetic field, in that surrounding area, the force getting exerted in that surrounding area, in that the compass are placed. Okay, similarly if you place a iron clinch, okay, iron small iron nail, okay, and if small iron nail is getting attracted to this magnet, it means that that iron small nail, the iron nails are placed inside the magnetic field. So what is magnetic field? The force exerted by a magnet in a surrounding area is called magnetic field.